Good morning, Sean here, Mountains Garage. A few videos back, I mentioned I'm going to build for myself another TH475, and I started going over the individual pieces that are going to go in it. We took the 4L80E drum out of the package, and I put an aluminum piston in it, and 6 clutches and steels. In that video, this was maybe not even 3 weeks ago, I mentioned I was buying these for $100. The 4L80E drum complete with the sprag, the spiral lock, the pressure plate, 5 new steels, no clutches. So it was a complete drum with no clutches. Over the next week, that went to like $135 to $140, but they were still available. Now they're unavailable and they're over $200. For the same $100 to $120, you get an empty drum. No sprag race, no spiral lock, nothing inside the drum. What goes up must come back down. I hope they do. And I don't think it has anything to do with what I mentioned, but I don't know. In a different video, I went over the 4-clutch intermediate that I'm going to run and how to do that. And I mentioned I was going to buy a new forward drum with an improved input shaft, which I have right here. It's an ATI. And today we're going to set that up. The forward drum and input shaft area is kind of mysterious. We got to go over a few things about the lube circuit holes and the bushing in the converter, if you have one. So let's dive into that. A side-by-side comparison. My new ATI pot number 406,000, 300M input shaft, and a reworked stock drum. This is a stock Turbo 400, which is a fine unit. The jury's still out as to what horsepower level it becomes in jeopardy of breaking, either here or they strip out the splines in the drum. It's common when you're buying a steel replacement drum, you're going to get a reworked stock drum itself with an improved input shaft. These come in different types of steel, with or without lube circuit holes. Lots to talk about there. This is the bored out OEM drum with the ATI shaft. You can see how big that is compared to the stock one. And this is a pretty rugged unit. You can imagine how much that improves the strength. Get them both in one picture. On the other end, looking at the lube circuit holes, these are now reduced to 1/4 inch. These are 5/16. The actual depth, that's stock Turbo 400. These are shallower by about 1 inch, which again makes the shaft stronger. They drilled minimal sized holes and depth for more strength. The stock Turbo 400 input, the holes go all the way through, whereas the ATI are now drilled on an angle and only go into the middle. You can see in this view that the 300M shaft is actually reduced in size compared to the 400 shaft, which is basically straight. Looking at the front pump assembly that I have sitting on the bench, this bushing here, the forward stator support bushing, is what we're going to talk about next. That bushing rides right here on the input shaft, and it supports the input shaft and inside the converter, the turbine. And this is where the mystery comes from. The majority of aftermarket torque converters have a bushed turbine, and you really don't have a need for this bushing anymore. The turbine is supported inside the converter, and it's redundant and restrictive potentially to still have the front stator bushing in the pump. If you spec a input shaft with no lube circuit holes, you definitely don't want the front stator bushing. So this is all based on what you have for parts. The mysterious part is, when I bought this whole unit, there's no instructions or guidance as to what is right and wrong. Like for instance, if I run a bushed converter with this setup, you can do it. And seemingly there's no downside. However, I expect in the future more information is going to come out on this subject. We'll see. Obviously it makes for a stronger shaft if there's no lube holes in it. So it's the majority of aftermarket shafts that you find do not have the holes. In my experience, I've put in a few of these. They're also necked down before the splines, so it doesn't even touch the stator bushing. If you have a bushed converter, which with a solid shaft you would definitely need a bushed converter. So my best advice is to be aware that this could be a potential problem area and contact the manufacturer if you already have your parts, or if you're going to buy the stuff, inquire as to whether you have a bushed converter, which I think most of them are anyway, a good quality converter. Look at your shaft, see what you have, and go from there. The drum comes empty, so you need to source everything else it takes to fill it up and make it a functioning unit. I have a nice set of relatively firm, I give them the squeeze test, stock return springs. I bought a new, this is an FTI billet forward hub. I have an aluminum apply piston that I'm going to need to machine. It's currently a 5-clutch piston at 740 thousandths, I believe. I have 6 new Raybestos waffle greens, 6 new steels, a nice used pressure plate, and where is it? Right there, that's normal. That machine part, it's a nice one. I have a belt sander right over there, and if these have hot spots or anything, I'll just hold it on there and take off the hot spots. And you need the spring retainer snap ring for that, which is sitting right there, and the external snap ring. So you need to come up with enough parts and lip seals when I finally put it together for the final time. When I'm stacking my clutches, I just throw the piston in without and stack everything up. In this case, I've already stacked it, and this has the perfect clearance for a 5-clutch unit. I want 6 clutches, so I measured 1 steel and 1 clutch. That's 160 thousandths. This is 740, so I'm going to end up around 580 thousandths, and I measure right to the raised portion right there. If you wonder what the raised portion does, that allows incoming oil to get under the piston and apply faster. If this set right down on the bottom and it had spring tension, it would be hard to get oil underneath to actually apply it. So that's what those 3 raised areas do. Okay, my piston is cut to about 582. That's where I stopped. You could probably hear it in the video when it goes over the voids. It's kind of noisy. So I'm just setting it in with no lip seals. You can tell immediately that the piston surface where it's going to push on the steel is above the groove in the drum. But it's always the first thing I eyeball anyway, just to make sure that the first steel can't go under the lip of the drum, because that would be bad. So now you just chuck these in. Again, I got to tell my brain to not put them all in the same. I do stack all the I like to look at the Raybestos label when I drop it in. And this is obviously just a mock stack up, so I'm not lubing, but I would soak them, at least get them wet before I put them in. Well, and we'll see what this looks like now. Just below the step where the, push right down on it, where the pressure plate's gonna sit. This should go in with a tongue. It does. You can hold down on this without even the snap ring. You pry up and down on the clutches. You can see your clearance. We're good. On to final assembly. You probably noticed I don't do any measuring, only because I know exactly visually and by feel what I'm looking for. But if it's your first time, the rule of thumb is 10 thousandths a clutch. Times 6, that'd be 60 thousandths. I'm going to be honest, I don't go that big. I assume when these are all broken in slightly, I'm going to gain clearance. So if I'm 30 or 40 thousandths, I'm pretty happy. Probably right around 40 thousandths. Because I figure everything's going to wear in a little bit, and then my clearance would be correct if you went by the law of 10 thousandths per clutch. But this is the way I've always done it, and will continue to do so. You don't want it too tight. You don't want it too loose. This isn't the story of the three bears and Goldilocks, but you get the idea. You've seen this part of the movie before if you've been watching the videos, but these are my Kentmore lip seal installer tools. They're fantastic. In a Turbo 400, they fit both the direct and forward drum. In a 4L80E, they fit the direct drum. Recently, I was asked, and it was brought to my attention, that the 4L80E direct drum installing tools have a different part number. I can't imagine why it would matter, because obviously you can use a 4L80E drum, and I use these on the 4L80E drum to assemble it. So I'm going to assume if you see them listed on the internet, then they're the same. Typical, I've lubed it with petroleum jelly inside and out. I've lubed the installer. This usually goes really easy, even with the camera on. I just twist away, and we're done. A little bit of extra lube on that baby, because no video is complete without saying lube 50 times, but you got to do it. That's what keeps it alive. Still spins in its place. That's nice. Open up my fine set of used springs. I have a lot of springs, both forward and direct, because I've stripped quite a few transmissions, but the directs, because you get a new set with a trans brake that are firmer. Again, I give these a squeeze test. These are actually pretty rugged, which is good. I'm okay with that. Stick them in there. This is, I didn't mention, this is a check ball drum. I have a non-check ball piston. I need to source some more pistons because I'm running out. I bought a whole bunch and I'm almost out. My spring retainer. Now let's put it in the press. Put the snap ring on. This is not my normal spring compressor. The one I normally use is over on another vise. I found this online in a closeout deal, and at first glance it looked exactly like my other one. Now that I have it home, I'm glad it was extremely inexpensive. I paid $28 for it. It needs a lot of work. It's almost non-usable. Despite looking the same, I got it down there and I think I can get the snap ring on, but this thing is not impressive, to say the least. In fact, I still got to go down more. Let's hope it doesn't explode in my face. There we go. You want the snap ring opening to be between the bumps. Too far. Right about there. Again, this thing is a weapon. I can fix it. I'm glad it was inexpensive. I figured it'd be nice to have a second one when I'm working on this bench. Again, it was midnight. I have a hoarding problem. We've been there before. I did not soak the clutches today because this is going to sit around for a few weeks and I don't want it oozing everywhere I set it. I'll disassemble it before I install it in the transmission for the final time and lube it up, don't you worry. The forward hub, you can choose to set it in there and stack the clutches around it, or you can wiggle it in afterwards. Either way, if you wiggle it in afterwards, you'll know when it's all the way down. Typically, there is a brass thrust washer underneath and a nylon thrust washer on top. You can upgrade to a Torrington bearing here. You can use the one, I believe it's the Torrington that's in next to the output shaft. You need to machine the direct drum to accept it and machine some off here. For this transmission, I'm not going to, just upgrading to a brass thrust washer on both sides of the forward hub. So we'll stick it together, and for today, we'll call it done. Having all the sub-assemblies done and ready makes for a fast transmission rebuild when you actually get around to doing it. So my 3 clutch packs are ready to go. When I get around to building my 475, there's lots of other parts kicking around here for it. You might have caught some in the background. We will go over them in the future, as they say. So that's it for today. Like, share, subscribe. Hope you got something out of it. Who knows what we're doing next? Probably back on the old Jericho to finish up the shifter. Have a good weekend.